Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. In our previous session, we have learned that how to convert a PWM signal into analog voltages and how to display the feedback voltages on LCD display. In this session, we will develop a circuit of serial communication, that is Rs232 interface, to communicate our embedded system with the computer, or we can communicate our RTU with any HMI which has serial interface. First, we will understand that what is Rs232 interface, then we will develop a circuit here on this portion of our Vero board. Here we can find a Rs232 IC, that is ICL232 or MAX232. ICL232 and MAX232 are the integrated circuit to convert the logic level, that is from 0 to 5 volt, into two levels, that is plus 10 volts and minus 10 volts. And here we can find the internal architecture of the integrated circuit, that is MAX232 or ICL232. ICL232 is a dual Rs232 transmitter and receiver interface circuit that meets all EIA Rs232 and V.28 specifications. It requires a single 5 volt power supply and features two onboard charge pump voltage converters which generate plus 10 volt and minus 10 volt supplies from the 5 volt supply. Here we can find the connection diagram for null modem configuration. In a null modem configuration, only 3 wires are required, that is RX, TX and ground. We'll use the same configuration of null modem in our prototype. Here we can find a standard connector for Rs232 interface, that is DB9 connector, and here we can find the signal descriptions of Rs232 interface. We'll use only 3 connections of the Rs232 interface, that is pin number 3 transmit data, pin number 2 receive data, and the signal ground, which is pin number 5. As most of the modern days laptops and computers are not equipped with serial communication, that is Rs232, so we'll use an interface, that is Rs232 to USB converter, to interface our RTU with computer. And here we can find the circuit diagram that we will use in our prototype. We'll use 4 1 microfarad capacitors for charge pump operation, and we'll use a converter circuit, that is ICL232, to convert the TTL level into plus minus signal. Here we can see in PIC16F877A microcontroller we have 2 separate lines, that is RX and TX. Pin number 25 and 26 of PIC16F877A can serve as Uart communication port. Here we can find pin number 25 is transmit data and pin number 26 is receive data. And here we can find the signal conversion of MAX232 or ICL232 interface. The logic level 5 will be converted into minus voltages and the logic level 0 will be converted into plus voltages, and these plus minus voltages can vary from minus 10 volts to plus 10 volts, and the output signal can have the voltages between these two ranges, that is from minus 10 volt to plus 10 volt. Without using MAX232 and ICL232, we can also communicate over TTL level, but the length of the communication will be restricted to the 10 meters. Using MAX232 and ICL232, we can communicate over a distance of 50 meters. Here we can find 2 configurations for serial communication, that is null modem configuration and SPI, that is serial programmable interface. SPI interface uses 4 signals, that is serial clock, master out serial in, master in serial out and chip select. In this configuration, the communication between master and slave depends on the serial clock. On rising edge of the serial clock, master station places the data on MOSI pin, and on falling edge of the clock, slave station will place the data on MISO pin. So in SPI configuration, master and slave communication depends on the serial clock. In null modem configuration, there is no need of synchronization clock. In null modem configuration, the communication depends on baud rate. In digital communication, the baud rate is defined as bits per second. Null modem communication is a full duplex communication, while the SPI communication is half duplex communication. First, master will initiate the request to the slave, then slave will respond to the master. But in null modem configuration, both the station can transmit and receive the data simultaneously. That's why it is called a full duplex communication. And here we can find a Uart data packet. In Uart data packet, data starts from start bit, which is always low. Then there are data bits, which can have 5 or 8 bits as per requirement of the communication. After the data bit, there is a parity bit, which can have even or odd parity. The parity bit depends on the number of ones in original data. Here we can find we have 4 ones in the original data, and the even parity is 0 and the odd parity is 1. And if we have odd number of ones in original data, then even parity will be 1 and odd parity will be 0. Similarly, we have only one number of 1 in original data, and the even parity is 1 and odd parity is 0. Here we can find what is baud rate and bit rate. As we have discussed that standard packet of Uart consists of 11 bits, that is start bit, 8 data bits, 1 parity bit and stop bit. In most of the communication protocols, we can ignore the parity bit and we can have some other checks to validate the received data. That could be checksum or CRC technique, but the start bit and stop bit must be there in every Uart packet. Here we can understand the difference between baud rate and bit rate. Here we can see bit rate is number of bits per second and the baud rate is number of symbols per second. If n is the number of bits per symbol, and if the symbol is composed of only single bit, that is 0 or 1, then we can say bit rate and baud rate is same. And if the symbol is composed of 4 bits, that is in case of A to D conversion, and if the baud rate is 1000 symbols per second, then the bit rates will be 1000 multiplied by 4, which is equals to 4000 bits per second. Here we can find standard baud rates, which include 110 bits per second, 300, 600, 1200, 24, 4800, 9600, 14.4 kilobits per second, 19.2 kilobits per second, 38.4 kilobits per second, 57.6 kilobits per second, 115.2 kilobits per second, 128 kilobits per second, and 256 kilobits per second are the standard baud rates for serial communication. And now we'll develop Rs232 interface circuit. First we'll place a 16-pin IC base in our Vero board. Here we have inserted a 16-pin IC base in our Vero board. And now we'll connect a 0.1 microfarad 50 volt capacitor with pin number 15 and 16 of ICL232 interface IC. Now we'll connect pin number 16 of ICL232 with plus 5 volt and pin number 15 with ground. To connect 5 volt and ground with ICL232 interface circuit, we'll use a wire bridge. And here we have inserted the wire bridge in our Vero board. And here we have ground connection very near to pin number 15 of ICL232. So we'll connect this ground connection with pin number 15 of the 16-pin IC base. Here we have completed the power supply circuit for ICL232 interface. Now we will connect 4 1 microfarad 16 volt capacitors with ICL232 interface. These capacitors are used to develop the charge pump circuit for ICL232 interface. First we'll connect C15 between pin number 16 and pin number 2 of ICL232 interface. Pin number 2 will be connected to the positive end of C15 and pin number 16 will be connected to the negative end of C15. Here we have connected C15 in our circuit, and now we'll connect C16 between pin number 1 and pin number 3 of ICL232. Pin number 1 will be connected to the positive end of C16 and pin number 3 will be connected to the negative end of C16. Here we have connected C16 in our circuit, and now we'll connect C18 between pin number 4 and pin number 5 of ICL232. Pin number 4 will be connected to the positive end of C18 and pin number 5 will be connected to the negative end of C18. Here we have connected C18 in our circuit, and now we'll connect C21 between pin number 6 and pin number 15 of ICL232. Pin number 15 will be connected to the positive end of C21 and pin number 6 will be connected to the negative end of C21. Here we have connected C21 in our circuit. Now here we'll place the DB9 connector to interface our RTU with master terminal, and here we have DB9 connector to interface our RTU with master terminal, and here we can find we have pin number 1 on upper rightmost side, pin number 1, pin number 2, pin number 3, 4, 5, pin number 6, 7, 8 and 9, And from the back we can see pin number 1 is here, pin number 1, 2, 3, 4, 5, and pin number 6, 7, 8 and 9. We don't require pin number 6, 7, 8 and 9. We will use only 3 pins, that is pin number 2, pin number 3 and pin number 5. Pin number 6, 7 and 8 are not required in our circuit, so we'll cut these pins to insert the DB9 connector in our Vero board easily. We'll also cut one pin from the holding pins. And here we have bent these pins to hold the connector in our Vero board. Now we'll insert the DB9 connector in our Vero board. And here we have inserted the DB9 connector in our Vero board. We'll also solder these holding pins in our Vero board to hold the DB9 connector firmly in our Vero board. Here we have inserted the DB9 connector in our Vero board. Now we'll complete the connection from DB9 connector to the Rs232 interface, and we'll also complete the connection from Rs232 interface to the microcontroller. Now we'll connect pin number 5 of the DB9 connector to the ground. And here we have pin number 1 of the DB9 connector, that is pin number 1, pin number 2, 3, 4 and 5. First we'll connect pin number 5 of the DB9 connector with ground. Here we have connected pin number 5 of DB9 connector with ground. And now we'll connect pin number 2 of DB9 connector with pin number 7 of Rs232 interface. And here we have pin number 2 of DB9 connector. We'll connect pin number 2 of DB9 connector with pin number 7 of Rs232 interface. And now we'll connect pin number 3 of DB9 connector with pin number 8 of Rs232 interface. Here we have inserted a jumper to connect pin number 3 of DB9 connector with pin number 8 of Rs232 interface. Here we have connected pin number 8 of Rs232 interface with pin number 3 of DB9 connector. Now we'll complete the connection between Rs232 interface and the microcontroller Uart. And here we can see from the schematic that pin number 25, that is TX of the microcontroller, is connected with pin number 10 of the Rs232 interface. So we'll connect pin number 25 of the microcontroller with pin number 10 of the Rs232 interface. And now we'll connect pin number 26, that is RX pin of the microcontroller, with pin number 9 of the Rs232 interface. We have completed the connection from DB9 connector to the Rs232 interface, and we have also completed the connection between microcontroller and Rs232 interface. Now we'll perform a power supply short circuit test and continuity test of our newly developed circuit. Now we'll check the 5V power supply connection for our newly developed circuit. And here we have 5 volts on pin number 16 of ICL232 IC. Okay, 5 volts are connected with pin number 16 of ICL232 IC. Now we'll check the ground connection. Okay, ground is connected with pin number 15 of ICL232 IC. Pin number 10 of ICL232 is connected with pin number 25 of the microcontroller. Okay, pin number 10 of ICL232 is connected with pin number 25 of the microcontroller. Pin number 9 of the ICL232 is connected with pin number 26 of the microcontroller. Okay, pin number 9 of ICL232 is connected with pin number 26 of the microcontroller. And now we'll perform a power supply short circuit test for our newly developed circuit. Okay, there is no short circuit between 5V power supply and the ground connection.